Over here. All right, good morning and welcome to everyone. We are starting with day 3. So we've been taking this little chunks at a time, right? And we're going to be looking, beginning with example 3A, we're talking all about rational exponents. And so our focus really has been this whole rational exponent property, where we're kind of going between having fractions in our exponents and using the radical sign and what exactly that means, okay? So let's start off right here. We have, it says simplify, and we have this right here. I'm going to go ahead. I'm just going to write it to the side because it helps me see it. Like if I do it like this, I'm going to write that rule down. And the rule is a to the power of m over n is equal to the radical, the nth root of a to the power of m. Okay. And so I'm going to be kind of labeling this right here. And of course, our a right here is 131. There's no multiple bases, so this makes it pretty straightforward, right? And then I have this. What's the one on top? M or N? M, very good. And then on the bottom, it is N. Okay. And it seems like the M is the one that travels with it underneath the radical, right? And we're going to put to the power of 1. And then in the index, that's where our n goes, we're going to put a 3 right there. So we're looking really for the cube root of 1,330 or 331. Yes. Can you put it in the calculator? Absolutely. And that would be a great. I do want to make sure that you are well prepared. At least you've been taught how to do it. Should you see this on a non-calculator portion of a SAT question, or if there's a couple other assessments that might come up in your future that are non-calculator. So any ideas? We got a number that ends with 1. What is 131 probably divisible by? Any ideas? It's not even, so not 2. Do you know how to check if something is divisible by 3? Okay, I'm going to show you. So basically, you take all the digits and you add them up. 1 plus 3, that's 1 plus 3 is 4, plus another 3, right? 7, plus another 1, and that's 8, right? And so if that final sum of all of those numbers, 1, 3, 3, and 1, is divisible by, if the sum of that is divisible by 3, then the entire number is divisible by 3. So can we divide 8 by 3? No. Okay. Any ideas out there what we can divide 131 by? 1,331? I'm going to take some stabs at it. Okay. Whoops. Y'all can chime in, please do. I'm just going to go ahead here. I'm thinking maybe 11 since it's got a 1 at the end. Yeah. And that looks like, yeah. So that might be another thing. If you have a 1 at the end, 11, because it's always like 11 times 11, it ends with like a 1. So I'm going to make my little factor tree. Let me do it in a little different color. I don't think it's going to be a huge factor tree. And I divided it by 11 and I got 121. And if I divide 121 by 11, what do I end up with? Yeah, there you go. Thank you, sir. And so I'm going to go ahead, put that underneath my radical. 11 times 11 times 11 is equal to 1,331. Okay. I have my group of 3. This index tells me how big of a group I'm looking for of factors that are all multiplying. And so what's going to pop out from under the radical? I have a group of 3 11s, and what's going to pop out? Oh, this is equivalent to? Yay, 11. Okay. So, and I can always double check it if I have access to a calculator, right? You could put it in the way you see it originally, just so there's less opportunities for mistakes. So when you do that, you can do it like this. 1, 3, 3, 1 to the power of, that's the button right below clear. And then you can put in a fraction the same way we've been doing it. Alpha y equals 1, 1 down 3, and to the right, make sure it looks the way you want it to look. And there we go with 11. Okay. Questions? All right. So I want to give you a 30-second head start on that. And I want you to put in what number you found that it was divisible by in the chat. That's really what I want. So in the chat, I'll give you a 30-second head start. Start playing around with some numbers. What do you think? You've got a number that ends at the 1. You can use my technique of adding up the digits. See if it's divisible by 3. It's got a 1. Maybe it's divisible by 11. I don't know. Check it out. All right. So I had people here. We have 2401, right? If you added them all up, 2 plus 4 is 6, and 6 plus 1 is 7. That's not divisible by 3. 3 wouldn't work. 7 seemed to work for folks. So you had 2401 divided by 7. You got 343. What'd y'all get after 343? Did y'all try by 7 again, or what worked?
7 and 49.
Okay, 7 and 49, and then 49 is just 7 times 7, right? And so when we look at that, we have, and I can kind of show you 2 different ways. One, we can definitely rewrite it, right? Where we have M on top, N on the bottom. The one that's going to go with it is M under the radical. So we have A is 2401. M is going to go with it, and N is for your index, which is sitting right there, right? And so this, of course, is the same as 7 times 7 times 7 times 7. We have the 4th root, okay? We have a group of 4, and out pops a 7, okay? One other method, would you agree that 2,401 is equivalent to 7 to the 4th power? Yes, that sounds logical. Okay. So what if I kind of replaced the base here with 7 to the 4th power and then raised it to the power of 1/4? Okay. According to my sheet, what am I going to do with my exponents here because I have a parenthesis? Multiply. So that just ends up becoming 7 to the power of 4 times 1/4, right? And 1/4 of 4 is 1. 7 again. You see that? Kind of slick. Okay. Any questions on this? All right, let's persevere. Let's keep going, okay? Let's take a look at example 4A. So here we want to simplify, yes? All right, so I'm going to go ahead. I'm going to start off with my tree. What's a good number to divide by? It's got an even number at the end. 2. And half of 32 is 16. Let's go. Half of 16 is? Half of 8 is 4, and half of 4 is? So there we go. We got 1, 2, 3, 4, and 5. 5 2s. Now, we could do it kind of either way. One way we could do it, we could say, okay, you know what? Obviously, 32 is equivalent to the power of 2 to the 5th power, right? And we could replace that base of 32 with 2 to the 5th. And we know that we're going to multiply our exponents. And that's 5 times 2/5, right? And that's supposed to be an exponent. Sorry, it's so large. Now, you can definitely, I'll put in the calculator first. You could do like this. 5 times alpha y equals 1, 2/5. You get 2. Or, since you're multiplying fractions, I like to think the 5 cancels out and it leaves you with a 2. So you're looking at 2 to the power of 2, otherwise known as, what's 2 squared? There you go. Okay. So that's definitely one way that we could do that, right? The other way, of course, is looking at our radical. I'll kind of make it look a little boop. You can use whatever method suits your purposes best. If I'm looking at this, I have, this is m, this is n, okay? I'm going to put it under my radical, 32 to the power of 2, because m is the one that goes with it, right? N is in my index, 5. Okay. And so what I'm looking at here, I got 32. And I know that 32 is 5 times, right? But here's the deal. If you do it like this, that means that we have, let me kind of do it again. I'm kind of squishing it in there, but 32 times 32, does it not? That's 32 squared is 32 times 32. And so what I'm going to do is I'm going to write 5 2s for each 32. So this one's going to be 5 times 5 times 5. Wait, I'm sorry, not 5s. What should I have done instead? 2s. I'm waking up. Okay. Let's do 2 times 2 times 2 times 2 times 2. That's for one of the 32s, right? And I'll multiply it times another. 2 times 2 times 2 times 2 times 2. Okay. Now I'm looking for groups of 5. Here's a group of 5. So what's going to pop out? A 2. And notice that I have another group of 5 2s. And so another 2 is going to pop out and they are going to multiply. And 2 times 2 is 4, the same answer. Just out of curiosity, which method do you like better? Just multiplying the exponents or putting it all into the radicals? Me too. I like that better too. I like the simple one. So choose whatever method you like and go ahead and do 4B, please. Okay, 2 different ways. I personally think this is the easiest way where I say, okay, 81, I do my little factor tree, and you should have ended up like 9 times 9, and then you get 3, 3, 3, and 3, right? And so that essentially tells us that we have 3 to the power of 4. Well, I can rewrite this so that instead of 81, I got 5 to the power of 2, right? Instead of 81, I'm going to plug in 3 to the power of 4, right? And what I do is I multiply 3 to the power of 4 times 5 over 2. You can put it in your calculator, but for the time right now, because I'm kind of running out of time here, this basically 4 divided by 2 is 2, and you'd end up with 3 to the power of 10, okay? And if I put that in my calculator, I get that beautiful number. But remember, it may not be in this form, it may be in that form, okay? Now, if I did it as a radical, what I would do is underneath the radical, I'm gonna take, I've got m on top, and I have n on the bottom. So my index is 2, and then I have 81 to the 5th power, right? So what that's gonna look like, if you drew it all out, you got 81 times 81 times 81 times 81 times 81. Right, that's 5 times. All right, let me show you something. We already have a couple groups of 2, do we not? Okay. And so out will pop an 81, right? Because we have that one. Out will pop out another 81. And we still have this one, 81 at home, right? Well, we know that 81 is also equal to 9 times 9, correct? So I'm going to go ahead and write it like this. 81 times 81. I'm running out of space a little bit. 9 times 9, yes. And so I have a group of 2. So what's going to pop out? 9. And I end up with 81 times 81 times 9. And let me double check it. Oops. And we get that same beautiful number. Yes. So I don't know, my advice, I really feel like when you substitute and you multiply the exponents, it's just a little easier. But if you really like drawing it all out, by all means do that. And if you have access to a calculator, make sure you're using the calculator to check your work, of course. Okay. Ladies and gentlemen, good luck on your practice today. Come back with any questions tomorrow. Have a beautiful day.